So this is Chapter 7 review. We're going to be doing the self-test and the chapter review in the back of Chapter 7 in your book. So we are starting on number 1 in the self-test. So we're going to evaluate x squared plus x to the 0 when x equals 1/5. And so anything to the 0 power is just going to be 1. So we don't even have to plug in right there. Before we even plug in, we can just make this x squared plus 1. Then we are going to have to plug in for x squared, which is going to be the 1/5 going in. So it's going to be 1/5 squared plus 1. Now 1/5 squared is 1/5 times 1/5. So think of it like this. So on top, you're going to get 1. And on the bottom, you're going to get 25 plus 1. And so that's just going to be 1 and 1/25. Or if you wrote that as just one improper fraction, it's 26/25. The main thing that they really want you to see there is that anything to the 0 power is 1. Okay, number 2. We're going to write this out using exponents. So however many times any term is multiplied by itself, that's the exponent. So there's 4 8s here. This is 8 to the 4th times. There's 6 of the variables d, so it's d to the 6th. And we've written it with exponents. Okay, there's no more that we can do. We could simplify 8 to the 4th if we wanted to, but since this is asking you to write it using exponents, that is all you can do. Okay, number 3. Again, we have something raised to the 0. So regardless of whatever they ask us to plug in for x, it's going to get raised to the 0. It's going to become 1. It's going to be 1 times 3. So let's show our work. Technically, we are plugging in 1,729 for x, but that just becomes 3 times 1, and your answer is 3. Number 4. So we have g of y, which means y is the variable that solves this function, 3y minus y squared. So when they say g of -2, you're just going to go ahead and plug in -2 for y everywhere you see it. Now it's important, if you're going to try and plug this all in your calculator, you got to use parentheses, otherwise it doesn't raise the negative part of this number to the exponent, which will change your answer. So if I'm just doing this out myself without a calculator, 3 times -2 is -6, minus -2 squared. -2 times -2 is +4, and -6 minus 4 is -10. Again, if you try and cram all that in your calculator and you don't get -10, then that's on you trying to put too much in the calculator and letting it do all the work. Okay, if you do put it in like this with all the parentheses, though, it will get you the right answer. But you got to be careful. Okay, number 5. We're going up here. It's $400 in an account, 4.4% interest. We're going to write and evaluate an expression. So starting to write it, we know it's b times g to the x when we're dealing with exponential. So the beginning amount is 400. The rate is 4.4%. You move that decimal 2 spots, so that equals 0.044. So our growth factor in parentheses is always 1 plus or 1 minus. Since this is interest adding on, this is 1 plus 0.044. And it's going to be raised to the amount of time, which in this case is 7. This can be rewritten as 1.044 when they're added together, and many of you just go straight to that, and that's fine. And your calculator will do the work for you. We're going to round this off because we are talking about money. It comes out to $5.40. Okay, number 8. For 8 through 10, we're going to use this. You bought a car in 2006. It cost this much money. It does depreciate pretty quickly. Okay, the value of the car, if you go to sell it a year later, is much less than what you bought it for a year earlier. So it's going down 16%, depreciates, going down off of 100%. So just like we did 1 plus the percentage when it's growing, we're going to do 1 minus the percent when it's going down. So the growth factor, that's g, that is this 1 plus or 1 minus. So it's going to be 1 minus, because it's depreciating, 16%, which is 0.16. Okay, and think about it like 100 minus 16, it's 84%. And so your growth factor is 0.84. Now, number 9, they want you to go ahead and take that equation, write the function m of x. So you're going to say m of x. Instead of a equals or y equals, m of x equals, and then you're going to write this in terms of x, which is what we're used to. So we're going to start with b, the beginning amount, 34,975, times our growth factor of 0.84 raised to the x. So there is the function m of x that approximates the car's value in x number of years. So now 10, using our function notation, m of 5 means that we're going to plug 5 in for x in our function. So we're going to raise this to the 5th. And after you run that through the calculator, it comes out to approximately 14,626.96. All right, number 11. For 11, 12, and 13, we are going to use this function, f of x equals 5 times 0.74 raised to the x. So you're starting with 5 of something, and it's going down by 26%. Where did I get 26%? 100 minus 26 gets me 74%. So I know if I'm going down to 74% for each amount of time, that means I'm losing 26%. All right, so for 11, we're going to do f of 1, which means you're just going to go ahead and plug in 1 for your exponent. That comes out to 3.7. 12, we're going to do f of 5, which means we're going to plug in 5. And rounding here comes out to approximately 1.11. 13, f of 7, 5 times 0.74 raised to the 7th. Again, rounding, approximately 0.61. Okay, 14 through 16, we're going to use this graph, which is the function absolute value of x minus 3. So we're going to determine f of negative 12. You could try and follow the graph up. It's not pictured, but you could kind of figure it out if you kept this line going, what it's going to be. Or we can just go ahead and use the equation. So it's the absolute value of x, which we're going to plug in negative 12, minus 3. So that's the absolute value of, solve the inside, negative 15. And absolute value means you're going to make it a whole number, and this is positive 15. 15, what is the range of this function? The range is going to be all non-negative numbers, but I want you to write it as an inequality. That's what the book answer says. But we know that the range of this entire function, the smallest y value is 0. And then everything above 0, all your positive numbers, are going to be a part of this because the arrows point up, meaning it's going to go on forever and continue to hit every single positive number through infinity. And it's never going to hit a negative number. So it's 0 and up. So we would say y greater than or equal to 0. (16) If the domain's now restricted to where x is greater than or equal to 5, what's the range? So if you just went on the graph, if you're looking at just x equals 5 and up, the range is from this point, which we'll figure out. It looks like 2, but we'll double check that. And then it's just going to go up from there. So it would be y is greater than or equal to 2. Now what we want to do is we want to actually double check that because we're guessing on the graph. So if you go to the actual function, f of x, and we plug in what we want. We want to know what's the value at 5 because we know it's going to go up from there, but this is going to be the minimum value. So you plug in 5. It's going to be the absolute value of 2, which is 2. So we know that at 5, this function's at 2, and we're only looking at this restricted zone from when x is greater than or equal to 5. So when it's at 5, we know it's at 2, and you can follow it over and figure that out. So when x equals 5, the range is at 2, and then it's just going to keep going up and up and up as we look at the zone x is greater than or equal to 5. So from 2 and up is the range, so this would be the correct answer right there. Okay, 17, we're going to sketch a graph of these functions. So for this, you're going to want to go to your calculator. And if you have a plot on from a previous question, you're going to want to turn that plot off because we're just looking at the equations. So I'm going to put this one in first, 30 times 1.05 raised to the x, and then 30 plus 2x. And then who knows what my window even is right now. If I just click graph, I get something here. But this doesn't really show me much. My window's not great. So first thing you could always do is hit zoom standard. And when I do that, I'm not going to see anything. And I knew that before I did it. But here's how I knew. If I look at both of these equations, I have a starting point. It's 30. Okay, that's how much you started with in an exponential. It's increasing by 5%. So starting at 30, going up a little bit, little bit, little bit. And over here, this is your slope and intercept. Intercept means it's going to start at 30, and it's going up. So if I'm going to go ahead and set my window to something that I can see all this, I'm going to need to adjust my x minimums and maximums, my y minimums and maximums, even more importantly. So right now my max is 10, and both of these are starting at 30 and going up. So let's make this much bigger. Let's make this 200. And we'll go up by a scale of 10. Let's go ahead quick and look. What does this look like? Now that's my exponential. You can see it's not curving very hard right now. So that really doesn't give us a great view of anything right now. So let's try this again. Let's put our x minimum out a little bit. Let's go to negative 30. Let's go our maximum to 50. Let's take a look at what that looks like. And the more x values that we allow in this window, the more you're going to start to see this curve up. Let's see what our line does. Line's going to cross in there somewhere. So that's a pretty good graph right there. So we got this curve coming through. We know it's going to hit at 30. We got this line. It's going to hit at 30 as well. Maybe cross over a little bit and then go. Okay, 18. Which one's greater, L of 9 or E of 9? So you could do this based on the graph if you really wanted to. Let me show you that real quick. If you want to go ahead and calculate the value, you do hit second and you're going to go to calculate. And when x equals, so that's what we're plugging in for here, L of 9, E of 9, we're plugging 9 in for x. You're going to hit value. And they want to know, okay, what's the value when x equals? We're going to put in 9. It's going to give you both of them, and you can jump between two of them. So you can see the blue one is worth 46.5, and the red one is worth 48. So in that case, the red is worth more, which is L. So L of 9 is going to be greater. Now, if you wanted to actually find the numbers, all you got to do is go back and plug it in. So you could just plug 9 in for x, run this in your calculator, plug 9 in for x, run this in your calculator. Again, it should make sense that it's 48 if you think about it. You're plugging in. 9 times 2 is 18 plus 30, that's 48. So you can use the graph or you can just plug in the numbers. And if you plug the 9 in here, you're going to get this 46.53. So lots of different ways to figure that one out. 19. Give an example of value when x of x, when L of x is less than, so when the line is less than. And so, I mean, any value out here, if you look, x is 33. Clearly, the L value, the line, is going to be less than the E value, exponential, anywhere out here. Okay, so I'm just going to pick an example of x equals 30. But any value out here where the line is below the exponential would make this true, where L of x is less than E of x. So number 20, we're going to write the equation and graph it. So we are increasing by a percentage. This is exponential. We have 76 million residents to start with. K is going to be the number of years since 180. So it's your starting point, which we're going to use 76 million. We're just going to leave it as 76. You just got to know whatever number you get is in millions. And that's going to be increasing. So it's 1 plus or 1.025. Don't put 0.25. That would be a 25% increase. 0.25. And they said raised to the K, the number of years. And quick sketch graph, your population will be starting at 76, and this is going to be exponential. It's going to curve up slowly but surely. 21. The circulation of the newspaper has decreased by 1%, so we are looking at exponential decay here. Starting point was 880,000. Let X be the number of months since the year 2000. So our starting point of 880,000 times, now remember it's 1 minus your percent, 0.01, raised to the X. This should be fully simplified though. You're not going to leave it as the 1 minus. So that is going to become the 99%. If you lose 1%, you're left with 99%, 1 minus 0.01. All right, and then on a graph, starting at a certain point, and you're going to have a little bit of a decrease, and it's going to swoop down. Okay, that's your exponential decay. All right, and then number 24, we're going to match these up. Letter A, this is a line, which is linear, and it's constant because it's a line, has a negative slope. So I know this is constant decrease. And all we have to do is match it up. It doesn't ask to explain. If we were going to explain, we would say this is linear because it's in y equals mx plus b form. And I know it's a decrease because of the negative slope. All right, letter B. That's an exponential form. So it's either exponential growth or decay. And you got to look at the number inside the parentheses. That's your growth factor. If it's more than 1, this is going to grow. So this is exponential growth. Letter C, also exponential, but now the number, the growth factor, is less than 1. So that is exponential decay. And letter D, slope-intercept form. Slope is positive, so this is going to be a constant increase. Even though it's a fraction, constant increase, I know there's a minus here, but that's the intercept. So it's starting at -7 and increasing by 2/3 for every x. Okay, so jumping to the chapter review on page 452. Starting with number 1, for 1 through 4, we're going to use the function f of x equals 10 minus 3x. So for number 1, we're finding f of 2, which means we're just plugging 2 into the function. So it's 10 minus 6, and so my answer is 4. Number 2, f of -4, just plugging -4 in. And now 2 ways to treat this. You can multiply and then subtract, or you can treat this as a -3, and a negative times a negative is going to be a positive 12, so that comes out to 22. Otherwise, you would have got -12, and it would have said 10 minus -12 if you just did the positive 3 times -4 and left subtraction alone. But then when you do minus and negative, it still goes plus plus, and we're going to get 22. Number 3, f of 1, let's solve that first. 10 minus 3 times 1. Well, that's 10 minus 3, right? 3 times 1 is 3, so that's 7. And then f of 0, 10 minus 3 times 0 is going to be 10 minus 0. So that's 10. And now if I'm going to add f of 1 plus f of 0, what I'm actually doing is taking these answers. 7 plus 10 equals 17. So you take your answer for f of 1 and you add it to your answer of f of 0. All right, now number 4 is different. It's f of this number. So this number here is 9, f of 9. And so we're going to just go ahead and solve that. And so it's going to end up 10 minus 27, and the answer is negative 17. So it is important to see the difference between those two formats there. Okay, number 5. Here's our function, 11 over 6 raised to the x. We're going to give the value of g of 2. So all we're going to do is take 11 over 6, and we're going to raise it to the second power. We'll do that right in the calculator. So I'm going to go ahead and put this in parentheses. I think it'll make life easier. I'm going to bring up my fraction, alpha x, 11 over 6. Close my parentheses and raise this to the second power. And it should make sense. 11 squared, 11 times 11 is 121. And 6 squared, 6 times 6 is 36. So my answer is just 121 over 36. Okay, number 6. H of x equals 2x to the third. So h of 4 just means that we are going to plug directly into that. So instead of x, it becomes 4 to the third. Notice I put in parentheses. I want to make sure that I do my exponents first. Okay, when you write this out. Now, if you do it all in the calculator, it knows to do exponents first. But really, if you do this in pieces, it's 4 to the third, which is 64, times 2, which is 128. Now, you could have plugged that all in at once, but you do need to make sure you understand what's going on with your order of operations, and don't always trust the calculator, because if you don't punch it in correctly and you try and put the whole thing in, you're not always going to get the right answer. Okay, so it's good to have, especially for simple math, we know do 4 to the third first and then multiply. It may help you to break that up into pieces. Okay, jumping to number 7. The final thing they want us to do is f of negative 1 plus g of negative 2. So you find the answer to this. So you're plugging into the function f of t. And then you find the answer of this, plugging into g of t with negative 2. And then you're just going to add those together. So let's do them separately real quick. F of negative 1 is plugging in negative 1 for t. So a negative times a negative is a positive 8. And then we're going to do g of negative 2. So you come over to your function of g, and you're plugging in negative 2. So 6 times negative 2. Okay, so that's negative 12. And now what they actually want us to do is f of negative 1 plus g of negative 2. So f of negative 1 is 8. G of negative 2 is negative 12. We're just adding those together. And my final answer is negative 4. Okay. Number 8. They give you these two functions, e and l. We want to find a value of m where the exponential, e, is less than the linear. So if I start plugging big numbers in, like 10, 10 plus 5 is 15, and 6 to the 10th is going to be a really big number, right? You could think about negatives, but I wouldn't even go that far. Let's just start with 0. You could try 1, 6 to the first, that's 6. And I put 1 in here, 1 plus 5, that's 6. They would be equal. But if you think of 0, 6 to the 0 is 1. Anything to the 0 is 1. And then 1 plus 5, if I plug 1 into this, is going to be 6. And therefore, the exponential would be less. So for number 8, I would just go with the answer of 0. Okay, we jump to number 12 after that. We've got this linear function here. We want to know what is L of 3. So you're going to go to your x-axis and find 3, and then just follow it up. L of 3 is 4. So whenever they're asking you for the value of the function, they're talking about the y value. When x is 3, it's 4. That's part A. Part B, what's the domain of L? These are not connected, so we cannot write this as an inequality and say everything between this and this. So you actually have to list these out. Domain are your x values, so you're just going to put them all on a list. 0, 1.5, 3, 4.5, 6, 7.5, 9, 10.5. Same thing for the range. list amount. I'm going to go in reverse order, just reading it from left to right. 6, 5, 4, 3, 2, 1, 0, -1. D, find a formula for L of x in terms of x. So L of x equals, this is a line. So we're thinking in terms of y equals mx plus b, right? So I already know what my plus b is. I know what it is. It's right there. Okay, it's 6. So it's going to be something x plus 6. So what I need to do is figure out what's my slope. Now I wouldn't necessarily judge it. Remember, it's rise over run. I wouldn't judge it on this one just because we end up at decimals. So you might as well just go to the nice whole numbers. So from this point to this point, starting with your y values, remember slope is change of y over change in x, which is your rise over your run. So I've gone down, I went from 6 to 4. I've gone down 2, so it's going to be a -2. And from 0, I've gone over 3. Okay, and that's a good final answer. This is a negative slope going down, down 2 over 3, down 2 over 3, starting at 6. Okay, 13. This function consists of only these numbers. So when I list the domain, it's literally just going to be a list of those numbers. So that's my x values for domain. So 2, 4, 5, and 10. Letter B, what's the range? Just list your y values, 200, 400, 500, and 1,000. And letter C, give a formula for f of x in terms of x. So again, we want to think about this, find our slope. You could go back to your point slope form. Okay, that's one way you could do it. Or you could just think about where this is going to go. So I would just look at these 2 points. We went from 4 to 2, and we went down 200, which means we went up 200 over the course of 2 numbers. So over one number, that would be going up 100. Okay, so I'm going to write this as a function, f of x, but I got to think y equals mx plus b. In terms of your intercept, we're at 400, and then we go from 4 to 2, now we're at 200. And so if I go from 2 to 0, which is going down another 2, I got to go down another 200. So that would be 0. So where this hits on my graph is going to be 0. So my intercept is 0. And again, my slope is going down, or actually it's not going down because we would go this direction from 2 to 4. It's going up 200 for every 2 x's that it goes over. My y values increase by 200 as my x values increase by 2. And then you would just go ahead and divide that. And think about it, if we had a third point here, okay, then the 3 would be 300, right? 2, 200, 3, 300, 4, 400. So it's going up by 100 every single time. So that makes sense. So f of x equals 100x.